Greetings to all of you. In today's session, we are going to discuss about the chemistry related with the intermediate, which will be helpful for your international entrance or any competitive exams if you are preparing for either for higher education or career opportunities in that regard. India level JEE advanced and JEE mains examination for engineering stream into IITs and NITs. So in Andhra Pradesh and Telangana, EAMCET examination, which is required for the entrance into engineering stream. In addition to this one, NEET chemistry for medicinal entrance examination. So all the competitive exams, whichever government notifications given by the national level exams or else TSPSC examinations are there. For all these, the kind of session will be very much helpful. The content retrieved from the previous year question paper, recently completed examinations were taken and detailed explanation will be provided to you. Let's enter into our today's session. Question number 1. It is related with the IUPAC nomenclature of the organic compounds, where compound number 1 is having the long chain of 8 carbons. In that, hydroxy is taken as the functional group. What will be the IUPAC nomenclature for the given compound? And the second compound is having 6 carbon chain length with the second and fourth carbons of ketonic functional groups. How can we assign IUPAC name for this one? Compound number 3 is having 6 carbon chain length, where 5th carbon is having ketone and first carbon is accompanied by the carboxylic acid. So highly oxidized one is taken as the higher priority, and this 5th carbon ketone will become a substituent over here. If you go with the compound number 4, in compound number 4, one end is having double bond, in either end is having triple bond. So there is an ambiguity in order to assign the numbering which will get the priority. Obviously, double bond will get the priority over triple bond. That's why we have to start numbering from right hand side. This is the way so many examples are provided. We have to assign the IUPAC nomenclature for the given organic compounds. Let's go with one by one. In the compound number 1, the chain length is 8 carbons. 6th carbon is accompanied with the methyl, so that 6 methyl to be taken. And being it is a carbon chain length of 8, it will become octa. Octa is given for 8 carbon chain length. On 3rd carbon, hydroxy is there. For hydroxy compounds, as per IUPAC, alkanol will be taken. 8 carbon octanol it will be. And this hydroxy is located at 3rd carbon, so that we can say 3-octanol. This is the way we can assign the naming for the given compound. 6-methyl 3-octanol is the complete name of given organic compound. When we go with compound number 2, parent chain is of 6 carbon length, hence we can say hexa. And the 4th carbon is having oxo. 2nd carbon is also having oxo, means ketone, but one of the ketone is taken as the main chain and another carbonyl group is taken as the substituent. So that, let me mention 4-oxo. On 2nd carbon, ketone is taken as the main functional group. That's why it can be included with the parent chain. Hexanone we can write. And this ketonic group is located on the 2nd carbon. Hence, we can say 2-hexanone. The complete name of the compound 2 is given as 4-oxo-2-hexanone. So, being both are ketones only, but in order to assign IUPAC naming, one of the ketone is taken as the substituent, another ketone is taken as the main group over here. Right? This is the way naming of second compound is done. Go with compound number 3, where you can find competing functional groups. One is ketone, second is carboxylic acid. Among the ketone and carboxylic acid, always a carboxylic acid will get the priority over ketonic one. So that 5th carbon oxo is mentioned and 6th carbon parent chain, so that hexa will be the one. And carboxylic acid, as per the IUPAC, alkanoic acid is the general name. So 6 carbon, so that we can assign hexanoic acid. Always need not to mention the first carbon number over here. So 1 hexanoic acid not required, because wherever carboxylic acid is there, there we have to start numbering. That's why need not to go for numbering for carboxylic acid. So that complete name of the compound number 3 is given as phioxohexanoic acid. Go with the compound number 4, which is the last compound as per the IUPAC nomenclature. Here, two ends are having double bonds and triple bond respectively. But we have to start numbering from the double bond end from the right hand side only, because double bond always get the higher priority over triple bond. That's why you start numbering from this right hand side and move on to left side, so that we can find 6 carbon chain length. First and third carbons are having 2 double bonds, so that we can write 1,3-diene. And the fifth carbon is having triple bond, so that 5-ine can be mentioned. And being it is the 6 carbon length, parent chain is hexa. So hexa 1,3-diene 5-ine is the complete name of the given compound number 4. This is the way all 4 compounds are assigned with the IUPAC naming as per the rules and regulations accorded by this IUPAC. So let's move on to question number 2. The type of methods to fill the tooth cavity. If anybody is suffering from the small holes or pinholes in the teeth system, so what kind of mechanisms we have to adopt? One is called cast gold filling, silver amalgam filling, tooth colored composites, all of these. These many options are provided, and what could be the right answer? Cast gold filling can be applied over here. Silver amalgam, amalgam means mercury. Silver amalgam can be used. Tooth colored composite materials also applied. So all are suitable options in order to fill the tooth cavities. Let's discuss in detail about one by one. Cast gold filling is nothing but gold is used as a filling one, and whose durability is extremely large, 10 to 15 years they able to withstand, and usually longer life will be there and corrosion may not be possible, and it is represented over here. Gold denticity is mentioned over here. Strength is highly large. When you go with the cast gold filling, the strength of filling will be extremely large. Move on to second one, silver amalgam filling. So this durability of silver fillings will be 10 to 15 years, longer duration will be there. And moreover, it is having tooth colored fillings and withstand chewing forces. Though you're chewing with this filled teeth, that will not impact the strength of this tooth system, right? So silver amalgam filling is another kind. Tooth colored composites will be there. So composite materials are able to fill in this exactly they resembles the tooth color. Nobody can understand where filling is there. So in this, the composite materials, which are the blends of so many components over here, they got existing in the color of the teeth itself, particularly suited for the front teeth. If any damage to the front teeth, in that case, we can apply this one. Bonding to the teeth structure. Composite fillings micromechanically bounded. So binding tendency is extremely large. We can easily manage that kind of system for the longer time. And versatility. Addition filling materials for decay. Composite filling can also be used to repair chipped, broken, and worn teeth. So if the conditions are chipped one, some part is already removed, our broken teeth is there, worn teeth is there, in that condition we can apt this kind of composite materials. Tooth sparing preparation. Sometimes let's say tooth structure needs to be removed, need not to go for the complete removal of the teeth, rather some part can be removed wherever damage is there. In that part only we have to go for filling instead of complete removal of the teeth. So we can remove the part where only the damage, where only curation is required, that part we can remove, and that part can be filled with this kind of composite material. So that these many ways we have to go for the tooth cavity filling. So for question number 2, option number 4 will be the correct answer. Move on to question number 3. This is the question given in the JEE Mains 2023 January examination, and it is purely from organic chemistry. This is the compound called acetophenone, and you can find chloro on the para position. Para-chloroacetophenone is the starting material and treated with sodium nitrile, NaCN. Whenever sodium nitrile is treated, this will participate in the addition reaction over here. Cyano will be attached to the carbonylic carbon and sodium will be attached to the oxygen, so that you can find sodium oxide. Then you can get the addition product. This addition product further go for acetic acid that will use to give the hydrolysis reaction. Acidic hydrolysis. Under acidic hydrolysis, whatever nitrile is there, that nitrile will be turned into carboxylic acid, and phenoxide, sorry, sodium oxide is there, that sodium oxide turned into OH. We can get the kind of material, we can see OH and COOH will be obtained. Then further treating with ethanol, this is the kind of esterification reaction under acidic conditions. We already got carboxylic acid as a P. Carboxylic acid that now treated with ethanol, esterification got carried, we get Q. And this is the Grignard reagent of excess. 2 moles of Grignard reagent when added, that will be treated at ester functional group. And we will go for further hydrolysis, and what could be the major product as R. That should be depicted. So the final product, after getting all these series of reactions, the final product is said to be OH, Me, C, Me, Me, OH. Chloro will not be impacted. We are not supposed to disturb this chloro at para position. Purely reaction got carried on this side chain where we have C double bond go CH3 methyl ketone that will be reacted. Let's see how can we go for this reaction. Whenever acetophenone, para-chloroacetophenone is treated with sodium nitrile, sodium cyanide, and here you can find Na plus and Cn minus. Cn minus will be nucleophilic addition at the carbonylic center. Subsequent shifting of pi bond towards the oxygen, O minus will bonded with the counter ion Na plus. We can say sodium oxide, and here nitrile is there. And further acidic hydrolysis, nitrile will be turned into carboxylic acid. ONA is converted into OH, so that we will get hydroxy carboxylic acid as a product P. This product P further treated with ethanol, carboxylic acid, ethanol. The kind of reaction is called esterification. Ester formation is possible. How? One H, another OH got removed as a water molecule under acidic conditions, and we will get a COOET. COOET will be generated. This is called ester. Okay, so the formed ester is called Q, product Q. The product Q now treated with 2 moles of methyl magnesium bromide. Whenever methyl magnesium bromide is treated, what happens? Here in this methyl magnesium bromide, this is called a Grignard reagent. Methyl is a negatively charged, magnesium is a positively charged. Negatively charged methyl occupies the carbonylic carbon and bond polarized toward the oxygen, and we will get OMGBr. OMGBr will be obtained. Another methyl magnesium bromide of another mole will be reacted. Subsequently, this ether will be removed. We will get dimethyl substitution, and on this oxygen you can find MgBr. That further subsequently hydrolyzed. Here H3O plus is also mentioned, hydrolysis under acidic conditions. Whenever hydrolyzed, this OMGBr converted into OH. Finally, the product will be, this is the called tertiary carbon atom, so that all carbons are, all the bonds are occupied with the alkyl, and here tertiary alcohol will be there, and this is also the tertiary alcohol. So this can be the final product. 2 tertiary alcohols containing product will be generated. That is seen in the option number 2. For question number 3, option number 2 will be the correct answer. Move on to question number 4. Uracil is the base present in RNA with the following structure. Percentage of nitrogen in the uracil is, right? So DNA bases, RNA bases only varied in this uracil content only. RNA contains uracil, DNA contains a thiamine. Okay, so that is only the difference. Remaining else is entirely resembled DNA, resembled RNA with the DNA. Okay, uracil is having the kind of system where you can find 6-membered ring. NH, C double bond O, C double bond O. Here double bond O is there. 6-membered heterocyclic ring system, and it is said to be a basic compound. And in this we have to depict what is the percentage of nitrogen in this uracil. Molar mass can be predicted as nitrogen atomic mass is 14, oxygen will be 16, carbon will be 12, hydrogen will be 1. Individual atomic masses are given to you. You have to depict the molar mass of the final product and the molar mass of the nitrogen as well, so that it is obvious to calculate its nitrogen content. In order to get that, it's a formula. If you see this, how many carbons are there? 1, 2, 3, 4 carbons are there. So that let me mention C4. And nitrogens are 2, N2, C4, N2. Count the number of hydrogens: 1, 2, 3, and 4. 4 hydrogens are there, H4. Oxygens are double bond O, double bond O. So that O2. So C4N2H4O2 is the molecular formula of uracil. And if you go for the calculation, 4 into 12 plus 2 into 14 plus 4 into 1 plus 2 into 16. This is the way, because all the atomic masses are provided and you have to go for the calculation for the molecular weight. C4N2H4O2 molecular weight is calculated as 112. Okay, so if 112 is the molecular weight of entire compound of uracil, what is the fraction of nitrogen? How many are there? 2 nitrogens are there. Each nitrogen is having 14 atomic weight. 14, here we have 2 nitrogens, that's why 14 plus 14, it will become 28. Nitrogen proportion, nitrogen content is 28. Total molecular weight is 112. Nitrogen atomic weight by total molecular weight into 100. That will be 28 by 112 into 100. So after calculating, we will get the percentage of nitrogen as 25%. This is the way we can solve the problem number 4. Very simple. Uracil is the base present in RNA with the following structure. Percentage of nitrogen is 25 in this. And this is another question, question number 5, which is collected from the recently conducted 2023 Telangana EAMCET examination, right? So here, if you see this, this is the 4 carbon chain. CH3, CH3 are located on this carbon, double bond CH2. We can say isobutene. What is the name? Isobutene is the name of the compound. Upon treating with CaMnO4 under acidic condition, acid catalyzed CaMnO4 reaction carried over here. Wherever CaMnO4 is added, there the breaking of double bond is possible, and that connected double bond connected carbon atoms will be turned into higher oxidation state around the central compound. Okay, this one end we have only one carbon, so that carbon dioxide, CaMnO4 used to oxidize into its higher oxidation level, that is carbon dioxide. And another end we have carbon with 2 alkyl. If only one alkyl is there, this carbon also converted into carboxylic acid. But we have 2 alkyl groups over here. That's why this carbon is converted into ketone here. X will be ketone here. And go with the compound number 2 called 2-butene. Upon treating with potassium permanganate under acidified conditions, what will be the product Y? So to get this one, let me cleave the double bond and let me add one side carboxylic acid and other side carboxylic acid. Being it is a symmetrical compound, the 2 products of oxidized one are exactly same. XY లలో ప్రమేయ సమూహాలు వరుసగా ఇక్కడ వచ్చే కాంపౌండ్స్ ఏంటి అనేవి మనం ఫైండ్ అవుట్ చేయాలి, రైట్? సో దిస్ ఇస్ ద క్వశ్చన్. లెట్ మీ గో ఫర్ ఆన్సర్ ఆఫ్ దిస్ వన్. For compound number 1, if you break over here, one of the carbon turned into carbon dioxide, that already given in the problem, so need not to solve. But else will be CH3C, CH3 will be turned into ketone. This is called acetone. This is called acetone. So X will be acetone over here, right? We can't convert into carboxylic acid because this carbon is accompanied by 2-methyl, so that it will be converted into ketone. If you go with second compound, we are having carbon with 1-methyl and another hydrogen. That's why both the carbons are converted into carboxylic acids only. Wherever you are cleaving, there you can find carboxylic acid, so that you will get acetic acid. So this will become acetic acid part. This also becomes acetic acid part, so that 2 moles of acetic acid will be generated. That is given in the option number 2. One is acetone X, one is acetic acid Y. So for question number 5, option number 2 will be the correct answer. Move on to, so here you can clearly see, whenever this compound called isobutene, upon treating with CAMnO4, the product is called propane 2-one. That is called acetone. Simply we can say acetone as the common name. Propane 2-one is called IUPAC name of the compound. Byproducts will be water and carbon dioxide. If you go with 2-butene, oxidation with CAMnO4, cleavage, subsequently we will get 2 moles of acetic acid like this. So this is the detailed explanation for the question number 5. Move on to last question of the session, question number 6. Identify the major product B in the given sequence of reactions. క్రింది చర్యా క్రమంలో ప్రధాన ఉత్పన్నం B ని గుర్తించండి. Okay, so what will be the product we have to identify? Initial compound is taken as the unsaturated triple bond called propyne. What is the name? Propyne is the name of starting material. Propyne is treated with hydrogen in the presence of palladium carbon. Palladium carbon is the reducing agent. In general, palladium carbon used to convert triple bond into single bond, means a complete reduction is possible, right? But we have to go for the step 2 reaction, where you can find C6H5CO taken twice OO, which is called benzoyl peroxide. This benzoyl peroxide is the initiator in the free radical mechanism, so that it will participate in the kind of addition with the HBr under free radical conditions, so that the product will be generated as a bromo substituted. We will see what will be the sequence of the reactions in order to achieve product B. The correct answer will be 1-bromopropane, right? So here 1-bromopropane will be the B product. Let's see how can we achieve this. In order to get that one, initial starting material is 1-propyne. 1-propyne treated with palladium carbon hydrogen. Palladium carbon hydrogen in general gives a triple bond into single bond. But what we are doing, we are to go for controlled reduction. Controlled reduction means only one double bond should be reduced. Controlled reduction gives rise to triple bond converted into double bond by adding one of the hydrogen. Later on, C6H5CO taken twice O2, this is called benzoyl peroxide. Under benzoyl peroxide, the addition reaction proceeded with anti-Markovnikov of addition, totally free radical mechanism employed. And addition reagent will be HBr, hydrobromic acid. One of the end will be added with hydrogen, another end is added with bromine. But anti-Markovnikov rule gives that where negative part of the reagent will be added to the carbon having more number of hydrogens under peroxide conditions is called anti-Markovnikov rule. So if you see this corner hydrogen is having, this corner carbon is having only one hydrogen, terminal carbon is having two hydrogens. So specifically, negative part means bromide. HBr negative part is bromide only. This bromine will be attached to the carbon having more number of hydrogens under peroxide condition. This is also called as Karash effect. This is also called as peroxide effect. This is also called as anti-Markovnikov effect. So this is also called as free radical addition. So many names we can assign for the given process. And finally, the product will be 1-bromopropane. If you remove this benzoyl peroxide, only HBr is mentioned, you have to achieve 2-bromopropane as the final product. In the absence of peroxide, 2-bromo is the final product. In the presence of peroxide, 1-bromo is the final product. Peroxide presence is called anti-Markovnikov. Only HBr is added called Markovnikov, right? So in this sequence, we will achieve 1-bromopropane as the final product, right? So initially, hydrogen reduction gives rise to triple bond converted into double bond. Propane is the A. The propane now added with HBr under peroxide, so that we will get 1-bromopropane. 1-bromopropane is the final product. By this, we completed the entire session of previous question paper discussion. Hopefully, this will be very much helpful for your preparation if you are really preparing for the examination with your all efforts. Definitely this kind of session will be very much helpful, and I will assure that if you are preparing seriously with this kind of content, it will really fetching for you. I'm requesting you to like the channel in order to get some kind of encouragement towards this channel, in order to get more such videos over here, and comment upon this video wherever the content is very much helpful for you, and share with other people who are really preparing for the examination and aspiring for the receive any kind of government jobs or else any entrance examinations. And subscribe the channel in order to reach out any future videos uploaded, any content if you retrieve really, so that you have to subscribe the channel. And thank you very much for your patient listening. Thank you one and all.